This epic video is an animation of the entry, descent and landing of NASA's Curiosity rover touching down the surface of Mars in August 2012. In my opinion, still one of the greatest engineering achievements in human history. Well, and in this video I'm gonna talk about the story behind this engineering work and why I think is very relevant to the software design discipline. Fasten your seatbelts, because we are ready to take off. When Adam Steltzner accepted the new Mars Science Laboratory mission in 2003, he knew little about the type and number of roadblocks that were going to get in his way to lead the entry, descent and landing the ideal team in putting NASA's Curiosity rover down on the surface of Mars. Or maybe he did know, as he explains in his book The Right Kind of Crazy. This book is full of cool stories about how Steltzner's career has been a cumulus of first-class problem-solving experiences that reached its peak in August 2012 when Curiosity touched down on the Red Planet. So let's now review my top 3 lessons learned from the book The Right Kind of Crazy and why I think they are very relevant to us software engineers. And of course, and as you may have guessed, this is something I talk about extensively in my book Building Software Platforms. So if you want to know more in detail, I have left a link to my book down in the description. So let's go with the first one, the least unacceptable solution. But first, let's study the problem. The entry, descent and landing challenge consisted of figuring out how to put a 2,000-pound unit of hardware on the surface of another planet floating 140 million miles away in the space. Of course, this was already solved in the previous mission, Opportunity. However, Curiosity was way larger and heavier, so the ideal team led by Steltzner had a few years to think on a solution. Now let's look at how Steltzner and the ideal team came up with the solution. First try, parachutes. This was a solution used already in the Opportunity mission, however the team struggled to find the proper parachute design and fabric composition for a safe landing due to the heavy weight of the Curiosity rover. This didn't work. So another option, airbags. I am sure you saw a few pictures of the Opportunity Mars rover covered in airbags, something like this. So the ideal team thought about using them for the Curiosity mission as well, but they quickly rejected the idea. This time, the team thought that the science equipment inside the rover could result damage because of an abrupt landing. And this is when they thought of a crazy idea, but the right kind of crazy, the sky crane. You can think of it of a super drone that retains the rover during descent and controls the landing velocity. Once the rover touches down, the sky crane sensors tell the machine to cut the ropes so it can fly off far from the rover. That's it, that made it. With the sky crane, the Mars Curiosity rover touched down the surface of Mars safely in August 2012. And now you may be asking, so Pablo, what does this have to do with software engineering?
We're sorry, the number you have dialed is not in service.
And well, it is how they arrived to the solution that is very relevant to software. It is true that I am not a big fan of comparing software engineering with other engineering disciplines, for example in the field of construction or manufacturing, especially during the build phase. However, there are very interesting similarities during the design aspect of it. So let's see them now. With an agile software development mindset, we would have started with an hypothesis and a lot of assumptions to reach a minimum viable solution in the shortest period of time. Then over time, we would be approaching the problem iteratively through experimentation and feedback from the real users until we got to the final solution. This is what we call an incremental design effort. As you can imagine, this could have brought a lot of challenges to the mission since getting feedback from real users is almost impossible. We can do tests and run simulations, but we can't ship MVPs to Mars in increments. So instead, the ideal team started by putting a lot of careful thought, relying on their technical judgment and reusing a lot of knowledge to get to the idea of the sky crane. The first prototype of the sky crane was already very functional and close to the final one, but in this case it only had one bridle that may have caused a lot of instability during the landing phase in Mars. So then, after some refinement by tests and simulations, they came up with the final solution by attaching the sky crane to the Mars Curiosity rover with 3 bridles. And here is where we can make the first conclusion comparing this design approach to software design. As Ken Beck says in his book Extreme Programming Explained, in the physical world, the individual transformations cost too much for incremental designs to work well. The intermediate stages have too little value or the changes are too costly. Or in other words, the cost of shipping versions of the intermediate solutions to Mars to obtain real feedback is absolutely not possible. That's why in this case upfront design based on careful thought and judgment was the right decision. And this is still a big deal in software engineering, the big question of when to design. And of course there is someone who has an answer for us. Again, as Kent Beck says, if pure thought creates most of the value without feedback, then designing sooner makes more sense. So in this case, designing based on careful thought at the beginning brought the most value to the mission. However, in software, an agile design approach brings more value when we rely on experimentation and feedback from real users after we launch a first minimum but viable product version. Alright, so big upfront design based on technical knowledge and judgment and careful thought was very valid for the Curiosity mission. But where did all that knowledge come from? Rocket science evolved from a novel idea that emerged around 1950 to the point that today space flights are so secure and extended that it became a commercial practice. Of course, all this enabled the coevolution of other practices that we are starting to witness in modern days with SpaceX and their attempts to interplanetary flights. Where is this going to take us? Who knows? Maybe to some sort of a space colonialism as a response to, I am not sure what's the need by humans. I think we better take care of the planet we already have. Well, of course, everything depends on the angle from which you are looking. Maybe curiosity is the next big iteration after opportunity, and perseverance is the next big iteration after curiosity. Well, in any case, let's now look at lesson number 2 from the book that we can apply to software engineering. Holding on to the doubt. There is an approach to problem solving that Adam Steltzner introduces in his book as holding on to the doubt. So this mantra pivots around the idea of avoiding fear-based decision-making, which only leads to hasty answers to the problems, in favor of curiosity-based decision-making. This approach leverages the essence of your attributes as an engineer to tackle the root of the problem and come up with much better innovations. And this made me think that the most common error of an engineer is to optimize the thing that should never exist. And to avoid that, problem restatement is a very powerful yet underutilized tool. We should favor elimination over re-engineering and, as Steltzner says, hold on to the doubt in order to get to the root of the problem. Or, as Kent Beck says, the rule of the 5 whys. If you ask why 5 times when you are analyzing a problem, it's very likely that you get to the root of it. And it is very likely that it's not a technical problem, but a people problem. And the most important thing that we learn from Kent Beck is to embrace change when we are designing software. And this is very important. As we favor elimination over re-engineering, we should favor re-engineering over duplication. You know, we should be very careful with those endorphins that we get when we design abstractions. Especially hasty abstractions. Or, in Martin Fowler's terms, I think we should favor more harvested frameworks over foundational frameworks and let the natural patterns emerge. This is pure human-centric design. Okay, alright, so after this rant, let's look at lesson number 3 from the book. Appreciating the mundane. I am going to use first only the value chain of a worldly map to represent what Steltzner refers to appreciating the mundane in his book. Let's suppose the main need is exploring Mars, so we need a rover equipped with scientific tools. To get the rover to Mars, we need things like a propulsion system, a navigation system, and the sky crane to land the rover on the surface. Each of those systems are built upon pieces such as parachutes and software, but also with other pieces that are taken for granted for the success of the mission, such as batteries, radios, receivers, or parachute fabric. That is the mundane. Utilities that even when you could buy them from your local hardware store, they are crucial to the mission, yet invisible to the important stuff, which is exploring Mars. Then, if we represent this model with a complete worldly map, including the evolution line, we can see how the mundane is nothing but industrialized commodities. And it is this dependency which needs to be solid. Again, all it takes to bring down your unique mission is a failure in a piece the likes of which you could have bought in your local hardware store. That's why the best way to appreciating the mundane is to consume them as commodities and not building them yourself. Instead, rely on the masters of industrialization whose job is to make those pieces as per the best industry best practices. So then, what's the mundane in software engineering? Let's answer this question with an example. And this is where things start to get interesting. Facebook was very well known during the 2000s because of their unorthodox mantra of move fast and break things. Although many other companies tried to copy that mentality, only Facebook could operate like that until they couldn't. When Facebook turned into a platform used by millions of developers to build and sell their applications, they couldn't ship broken features anymore. That is when Zuckerberg in 2014 shifted gears and told everyone that Facebook was still moving fast with stable infrastructure. And as we have learned from the Curiosity mission, the best way of having stable infrastructure is by appreciating the mundane. In our case, this means relying on cloud providers as masters of industrialization and start consuming infrastructure as a utility. So let's see how. Using a worldly map, we can visualize how developers work as close as possible to their clients to deliver functional applications to solve business problems. That is the important stuff. This is the most important place in the chain, where the real value is created. However, we know that in order to build software, developers depend on a stable infrastructure. This includes things such as dealing with clusters, designing for resiliency and high availability, and patching and operating virtual machines. That is the mundane. Dealing with all that stuff is pure, undifferentiated, yet necessary work. Therefore, that's the reason why we want to consume these capabilities as managed services from cloud providers. In any case, it is not that simple. Although part of the complexity is now managed externally, we have new problems. Because complexity is like energy, it does not go away, it is just transformed. This new way of building modern applications, represented by the highlighted line, is actually adding extra cognitive load to the developers. In other words, developers now must navigate a new ocean of engineering responsibilities that didn't exist before. What does this mean? Well, I have changed the worldly map to visualize this new challenge better. The map is now anchored to the developers as the main user, and it is focused on the co-evolution of practices enabled by the introduction of serverless. So what are all these new engineering responsibilities? First, developers can do their own architectural design without depending on the figure of a central architect. Also, we now have more infrastructure APIs and infrastructure as code tools to create infrastructure programmatically, so that is something they can do as well. And lastly, we need even less operations interventions, moving from DevOps to NoOps, which means that automation scripting is also something that developers can take on fully. All that is the new ocean of engineering responsibilities. So again, we need to find ways to help developers in this new world of software development and empower them to focus on solving business problems with quality software. How can we do that? A potential solution is building an internal software platform and offer it as a managed service to the developers. Again, we can visualize this idea better by switching back to a worldly map anchored to the final client. You no longer need to buy a product to empower developers and cover all their needs. Instead, building your stuff in-house is much better. That is why internal software platforms are built in-house and invisible to the eyes of the final customers. These end users receive the value that platforms help to unleash in the form of better functional software. And what is this value? Mostly, it is reducing the cognitive load of developers by absorbing all the transversal and infrastructure responsibilities so they can focus on building software that the end customers will love to use. Let's see this in detail again. There are 4 areas where internal software platforms can help empower developers. 1. Industrialization of cross-cutting functionalities into a set of core services at the disposal of the developers to build business capabilities. Second, the heavy lifting of a standard stable infrastructure with a physical landing zone where developers can drop their business applications without worrying about setting up basic connectivity, authentication, logging, monitoring, and so on. 3. Rationalization of cloud-managed services by filtering the access to an overwhelming catalog of cloud services and offering configuration manuals. And finally, a curated developer experience with abstractions and encapsulations fully tailored to the particular needs of the developers in your organization. And with that, until next time, so thanks for watching!